Good morning. Good morning, everybody. And guess what? I'm really happy to be here. I'm really happy to be here. And this is kind of the best part of the day. I was waking up this morning. I was like, every few weeks, I don't like feel like perfectly great. And I kind of felt like that this morning, but I was like, I gotta do my TV show. And so I just have 2 slides today, but I'm also kind of procrastinating because I want to give you guys an action shot of like actually killing them softly, and like what I have in my mind of this like, proof sort of setup. Okay. But it's kind of hard, so I'm kind of procrastinating that a little bit. I'm sure like tomorrow I'm gonna feel super good again. Okay. So anyway, I'm just like super happy to be here. I love doing this, and I thank you so much for all the subscribers and everything, you guys. So today today I was gonna, again, kind of procrastinating putting off the killing a inaccessible cardinal softly. Now, the talk isn't about. Sorry, guys, I have like. The talk isn't about the inaccessible cardinals or the Mahlo cardinals. It's about super compact cardinals. Also, like, I want to do an action shot of killing measurable cardinals softly, but okay, again, that's the hard stuff. Okay, so the first slide is I wanted to put down Mahlo cardinals and their degrees. A cardinal kappa is Mahlo if it's inaccessible, and the set of inaccessible cardinals below kappa is stationary in kappa. Okay, I think I just had to say regular there, or in my thesis I just say it's an infinite cardinal kappa is Mahlo if the set of inaccessibles form a stationary set. So I like this image of the like cloud. I don't know if other people like this image, but like to me it's like a closed unbounded set is like it's unbounded in the cardinal and then it includes its limit points. So like if it had like unboundedly many finite numbers, then it would also include omega. And I always think it's interesting, like the like topology or the like analysis that comes into set theory, because I liked real analysis. I mean, I thought I was maybe going to do real analysis or complex analysis or something like that, but I feel like it's too smooth. It's too like, I like the discrete, but like set theory sort of has a little bit of both. It like so like when something to me like when someone you're talking about limit points, I sort of like I kind of like freeze because I'm like I don't want to talk about limit points and like I don't know, like all that like real analysis stuff. So it's like, but it's sort of it's not so. I don't know how to say besides like kind of like a smooth like thick or like something that's sort of like it's like water, you know. It's like I'd rather deal with the droplets of water, I guess. But anyway, so that including having a closed and unbounded sort of makes sense, but closed just means like if you have like if you have a bunch of ordinals in there and they're heading in the set and they're heading towards a limit point, you include the limit point as well. And the limit point is just a limit ordinal. That's all. And I like that. Okay. So this idea that the inaccessibles form this like cloud at the top ish, so that they intersect every closed unbounded set. So I like this imagery. Okay, you can zoom in a little if you want. Okay. So a kappa would be 1 Mahlo if the set of Mahlo cardinals below kappa is stationary in kappa. So the set of stationary. So when we're talking about degrees of inaccessible cardinals, like the degrees reflect the original definition. So in inaccessible cardinals, it was all about the definition of inaccessible cardinals is all about limits. So in the degrees of inaccessible cardinals, it's like it's a limit of inaccessibles. And here, since Mahlo cardinals are about being stationary, it's the degrees are all about being stationary. In, you know, it's like the 1 Mahlo means that the Mahlo cardinals are stationary in you. Okay. Another thing I was going to mention. Oh yeah. Also, you know how I was talking about how like Mahlo cardinals like love inaccessible cardinals. Like a lot of the cardinals are sort of have this built-in like the next biggest thing after Mahlo cardinals is like weakly compact or something. You know, so it's like there's always like this next biggest thing to get to in the hierarchy of large cardinals. But Mahlo cardinals actually explicitly talk about inaccessible cardinals, like in their definition, which is interesting. And I don't know if there's other cardinals that are like, oh, I'm a certain kind of set of these kind of large cardinals. I'm sure there are, and I like Mahlo cardinals really do love inaccessible cardinals. Okay, they talk about them a lot. Okay, and then the degrees of Mahlo cardinals, which the degrees of inaccessible cardinals are really like based on the degrees of Mahlo cardinals, because the degrees of Mahlo cardinals were sort of laid out when Mahlo cardinals were originally defined, I think. Okay, don't quote me on the history, guys. But they have the same like setup as inaccessible, but instead of in limit, you replace it with stationary. Okay, and so they have all these. I wanted to include all the words. So like kappa is omega to the 7th Mahlo if it's vastly Mahlo. So we have all these hyper, richly, utterly, deeply, truly, eternally, vastly. What's to the 8th? I don't know yet. I guess we'll have to ask me. I don't know. No, I don't know what it is, but maybe we don't have to get that. I don't know. Yeah. So the words reflect. Again, we have the same kind of like roadblocks as we had with the inaccessible cardinals. Okay. So the next slide. Let's do the next slide. So we're getting a little bit into the killing degrees of Mahlo cardinals softly. Okay, so here's a couple of killing them softly Mahlo cardinal theorems. If kappa is Mahlo, there's a forcing extension where kappa is T inaccessible for every meta-ordinal T, but where kappa is not Mahlo. So you can separate with forcing. Another way to think of it is like instead of killing them softly, think of it as separating or distinguishing between large cardinals with forcing. So you can separate this idea. Maybe being Mahlo is being T inaccessible for any meta-ordinal T, but this is saying, no, you can force in between these two ideas. Okay, so you can have a forcing extension where it's no longer Mahlo. And another one is if kappa is T Mahlo, where T is a meta-ordinal term having parameters less than kappa, then there's a forcing extension V of G where kappa is T Mahlo but not T plus 1 Mahlo. So you can distinguish between individual degrees of Mahlo cardinals. And I feel like in that theorem how it mentions that kappa is T Mahlo, where T is a meta-ordinal term having parameters less than kappa, because that sort of points out what we were talking about last time, these roadblocks. And so when you have this meta-ordinal expression for the degree, you can't have parameters with kappa because that's where the roadblocks are. Like you can't be 1 hyper to the kappa because hyper to the kappa is richly. Hyper to the kappa inaccessible is richly inaccessible, and you can be 1 richly inaccessible, but you can't be 1 hyper to the kappa. So you wouldn't have kappa as a parameter in your meta-ordinal term describing your degree. That's just I like that extra information in the theorem. Okay, so these two guys are talking, and it sounds like a joke because it's an easy punchline, because it's an easy answer. So it says, how do you kill a Mahlo cardinal? And it says, add a club of non-inaccessibles. So this picture is supposed to show like there's like a break in the clouds where you have this club that's not intersecting the cloud. It's you have this club set that doesn't have any inaccessibles in it, so it can't intersect the inaccessibles. So okay, so it sounds like a joke because there's an easy answer and I think this has been around for a long time too. This idea of like if you add a club with forcing, you can do this and you can preserve things. You add this club and it's no longer Mahlo because you have the set of inaccessible. You have a club without inaccessible, so you can't have it intersecting the club intersecting the inaccessibles. Okay, so you guys, tomorrow I'm promise, and again, thank you for being here, and thank you for listening, and I'm really happy to be here. I kind of think of it like my job, kind of. I will have to go back to school though. I think it's gonna be fine, you guys. I get starting to get a little, I'm in this little town and stuff. You start to get a little like kind of needing to get out into the world, and so anyway, so I am like at first I was like, oh no, these 2 weeks are gonna go by so fast, and I'm gonna have to go back and but this can still continue when I have to go to school. So this semester, like randomly, kind of randomly, usually I'm like teaching a class, but this semester I had this opportunity because the school I'm nearby and I was teaching at last semester has this like, instead of in the tutoring center having like students or usually what they have is students, and I always want to teach in the tutoring center, but at this school they actually have the professors working in the tutoring center. So that's what I'm doing this semester, and so hopefully, and then I'm doing this, so I'm also like, what am I gonna do when this is all done? Because yeah, we'll figure something else out. Anyway, I've just been having a really fun time, and obviously I can't stop talking to you guys. Okay, yeah, I know my hair is kind of curly today. Okay, so I'll talk to you guys soon, and I'll see you tomorrow. Bye.